S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So in part 1 of this lecture, we did power series, then convergence and divergence of power series on the basis of radius of convergence. We did one example on power series. Now I'm taking few more examples to understand the concept of how we check convergence and divergence of power series. Hello everyone, welcome to S. Chand Academy. I am Dr. Seema Thakran. For engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. So my first example is nxn upon n plus 1. This is my power series, and you can see because xn, if there is xn, then it means this is power series. Now, what is nth term in this case? This is my nth term. I have only two formulas for radius of convergence. So, I am again applying I am changing it to n plus 1 because anyhow there is no power as such in nth term. So, it's better we apply this limit ratio formula, and I just check the limit. So, this will be n upon n plus 1 whole square, then n plus 2 whole square upon n plus 1, and now take out n common. So, because this is whole square, so n square will come out. So, 1 plus, then from here also you take out, this is n plus 1, n plus 1 again. So, n, if you take out n common from both, so 1 plus 1 by n, 1 plus 1 by n, this gets cancelled. When you will approach the limit to infinity, 1 by infinity 0, 1 by infinity 0, 1 by infinity 0. So, finally the limit is coming out to be 1. If radius of convergence is 1, what to say now on the basis of radius of convergence? That the series, the given power series is converging for mod x less than 1. It means the region is this. Then in which region it is diverging? Region of divergence mod x greater than 1. It means minus infinity to minus 1 open interval, union 1 to infinity. Now, I haven't checked for x equal to 1. You just check and you see what exactly the series will look like. So, for when x is 1, the series will be this. And if you apply the Cauchy-D'Alembert's ratio test, because only x you will miss, so it will come out to be 1, and for according to D'Alembert's test which we did in the last lecture, it will converge. It means we can make it closed interval, and I can write it. So, next question based on power series, and the question is xn upon n to the power n. So, what is the nth term here? It is n to the power n. Because the power nth term is in power form, so we will be applying the radius of convergence, that is our root power form, and the power form is this. So, power form is 1 upon limit an is 1 upon n to the power n to the power 1 by n. Just separate it. So, n will get cancelled, this. So, limit 1 by n tending to infinity. So, limit, when you are taking the limit, 1 upon n will give you 0. So 1 by 0 is ultimately infinity. It means R is infinity in this case. It means this series is also converging for all points. This series, this power series, because R is infinity, there is no end for the convergence, is converging for all points. Points means for all values of x. Points x. Now, another example, and that is summation n factorial n to the power n and xn. Now, let's see what exactly the radius of convergence will be. It is now in mixed form. Some power is in nth power and some is not. So, I will prefer, or we should apply the ratio formula for the limit. So, un plus 1 will be n plus 1 factorial upon n plus 1 whole power n plus 1. Take the limit and be careful that un will be on the top, because this is what I am applying the formula. If you are changing it, then radius of convergence concept also you have to change. This is our value. So, n factorial upon n to the power n limit into n plus 1 factorial. So, I have reversed this un plus 1 term because it will go, it is in denominator and it will get reversed. Take the limit carefully. So, n factorial upon n plus 1 outside into n factorial n plus 1 whole power n into n plus 1 upon this. So, this gets cancelled and this gets cancelled. We are left with n plus 1. I am combining the powers now. Anyhow, this is indeterminate form, but I have already told you this limit, and this is basically 1 plus 1 by, and this limit formula is E. So, it means this time my R is E, and I hope you remember the E value, that is 2.71 something. So, it means the radius of convergence is XE, and therefore, the region of convergence is little bigger than if we compare except infinity, because otherwise it was 1 only, mod x less than E. It means region of divergence is mod x, E greater than E. So, now the last example of the lecture, xn upon n cube, n from 1 to infinity. This is again power series, and I just expand this power series. This power series is basically x upon 1 cube, x square upon 2 cube, and so on. This is x square. What is the nth term in this case? And can you see that for the nth term, I am just not taking or not considering the xn term. So, un is this, un plus 1 will be n plus 1 whole cube. I will apply the un upon un plus 1 limit for formula. So, it is 1 by n cube limit 1 by n plus 1 whole cube limit, limit only once we write. So, this will go in numerator, and finally, we are getting limit n tending to infinity 1 plus 1 by n. Some of the students misunderstood and they compare it with this limit, as I did in earlier case. This limit is E, but this is not n. So, this is not E. If you are tending it to infinity, 1 by infinity, that is 0, so it is 1. And finally, your radius is 1. So radius of convergence 1 implies the region of convergence mod x less than 1, mod x region of divergence mod x greater than 1. So we did 4 to 5 examples for checking the power series convergence and divergence in this part 2. This is the end of part 2 now. For engineering mathematics, please refer to the book by S. Chand Publishing. The book is very good and you find the concepts very easy explanation for the questions, for the theorems, for the concepts. So please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching the upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.